Countdown pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Good afternoon, everyone. My name is Atticus Federa, and I'm a propulsion engineer here at SpaceX. I'll be your host for today's Starlink mission, which marks SpaceX's 21st launch of the year and 220th overall mission to date.
Pressing for strong back retract.
On your screen is a live view of our Falcon 9 rocket at Space Launch Complex 40 in Florida. At T-minus 4 minutes and 45 seconds, the range is green and ready to support, and weather is also looking good. The teams are currently tracking no issues with the vehicle or with the spacecraft. Now, coming up shortly, you should see those clamp arms beginning to open up just below the fairing halves there.
Strong back lower has started.
The strong back, or TE, transporter erector as it's sometimes referred to, is that truss structure you see supporting the vehicle. You can see those clamp arms opening up now. After they open up completely, you will see that strong back move away from the rocket. The strong back is the structure we use to support the vehicle in its horizontal position in the hangar. The strong back also helps us roll the vehicle out to the pad and raise it to its vertical position. In addition to structural support, the strong back also provides fluid and power connections through the umbilicals. As you can see there, that strong back is beginning to lean away from the vehicle in preparation for liftoff. Coming up next at about T-minus 3 minutes, we should hear that Stage 1 has completed liquid oxygen loading. Teams began loading propellant on the vehicle at about T-minus 35 minutes. As you can imagine, it takes quite a while to load 1 million pounds of liquid oxygen and RP1. Loading these propellants quickly is just one of the many ways that SpaceX has optimized the process of launching payloads into space.
Stage 1 LOX float is complete.
And with that, the Falcon 9 first stage is fully loaded with RP1 and liquid oxygen. We're just awaiting the completion of liquid oxygen loading on the second stage. Should be closing out liquid oxygen loading on the second stage in around 45 seconds at T-minus 2 minutes. Looks like quite a nice day down there in Florida. Should be getting some good views of the ascent and landing phases of our launch today. You can see the periodic venting of the cold gas in the area just above the tanks. When that gas contacts the moist Florida air, the water in the air condenses, forming those cloud formations.
Stage 2 LOX float is complete.
There we just heard that Stage 2 has wrapped up oxygen loading. With that, the Falcon 9 vehicle is fully loaded with 1 million pounds of fuel and liquid oxygen. Now this booster, or first stage, that you see on your screen is flying for the 4th time today, having previously supported Crew 5,
closeouts has started.
GPS 3 Space Vehicle 6, and Inmarsat I-6 F2. After liftoff and stage separation, this booster is scheduled to land on our drone ship. Just read the instructions, which you can see on your screen now. Coming up next, we should hear a call out over the nets updating us that Falcon 9 is in startup. This means that the internal flight computers have taken over control of the launch countdown.
Falcon 9 is in startup.
Good news there, the vehicle is in startup. In a few seconds, we should hear our launch director, or LD, give the final go for launch.
SpaceX launch director, go for launch.
And with that, we are go to proceed with our launch today. So let's sit back and watch as Falcon 9 takes our 56 Starlink satellites into space.
T-minus 30 seconds of counting. T-minus 15 seconds of counting. T-minus 5, 4, 3, 2, 1, 0, liftoff.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
At T plus 33 seconds, Falcon 9 has successfully lifted off from Space Launch Complex 40 in Cape Canaveral, Florida at 4:01 p.m. Eastern Time. Next major milestone coming up is max Q, which is the point where the vehicle experiences the greatest amount of external stresses as it ascends through the atmosphere.
Falcon 9 is supersonic.
Just ahead of max Q, we do throttle down the M1D engines briefly to reduce the loads on the vehicle.
Power and telemetry nominal.
Max Q.
And at this point, we have throttled those Merlin 1D engines back up to full power to continue to boost our way into orbit. Now we're about 1 minute away from a very exciting portion of our flight. We have a series of back-to-back events. Those are MECO, or main engine cutoff.
Back engine chill has started.
Stage separation, second engine start 1, and then after that we have fairing separation. MECO is when we shut down all 9 of those Merlin 1D engines on the first stage. Stage separation is when we physically separate the first and second stages from each other. And second engine start 1 is when we light that single Merlin vacuum engine on the second stage. And when we separate the fairings, you will get a good view of those 56 Starlink satellites on our payload.
Vehicle is following a nominal trajectory.
Got some great views here of the first stage ascent.
Main engine cutoff. Stage separation confirmed. And MVAC ignition.
And as you just heard and saw over the nets, we had successful main engine cutoff, stage separation, and second engine start 1. Coming up shortly, we will be separating those 2 fairing halves, and there they go. You can see those Starlink satellites now exposed to the vacuum of space. We will be attempting to recover those fairing halves today on our recovery vessel, Bob. Both of those fairing halves are supporting today's mission for the 7th time. On the left side of your screen is a view of the first stage, with the second stage and its Merlin vacuum engine continuing to burn on the right. You'll notice in that stage 1 telemetry that we are actually still coasting upwards.
Both vehicles are following nominal trajectories.
We will continue to gain a little bit of altitude as we slow down on the first stage before we reach the peak of the first stage's trajectory. At this point, the first stage will then start to accelerate back down towards the Earth to our drone ship that is waiting in the Atlantic Ocean. The MVAC engine attached to the second stage is continuing its burn. This should last about another 4.5 minutes or so. You can see periodic puffs of gas coming off of the first stage. This is our attitude control system. When we are above,
signal, Bermuda.
When we are above the atmosphere, there's nothing to react against, so we must use high pressured gas to reorient the vehicle. Currently, we are slowly flipping the stage to point those M1D engines in the direction we are traveling. And this is so that when we relight the engines ahead of entry burn, we will slow the vehicle down. You can see the first stage.
Vehicles continue to follow nominal trajectories.
The first stage now continuing to accelerate down towards Earth, and we are decreasing the first stage's altitude. As a reminder, Starlink is a satellite internet constellation designed and manufactured by SpaceX to provide high-speed, low-latency internet to people living all around the world, as well as remote and rural locations. As I mentioned earlier, today's Starlink mission marks SpaceX's 220th mission overall and our 21st mission just this year. Those 220 missions include all Falcon 9s, Falcon Heavies, and Falcon 1s. Coming up next in the mission is entry burn on the first stage. That's the first of 2 burns that the stage will go through prior to landing. This burn helps reduce the vehicle's velocity as it re-enters the thicker parts of the Earth's atmosphere. Should be starting up engine 1, 5, and 9 for that entry burn in around 10 seconds.
Stage 1 FTS is saved. Stage 1 entry burn startup.
There's that call out for stage 1 entry burn. As you can see, we are now slowing down the vehicle for atmospheric re-entry. This burn lasts around 20 seconds, so we should be wrapping up here shortly.
Stage 1 entry burn shutdown. Stage 2 FTS is saved.
There's that call out for stage 1 entry burn shutdown.
Both vehicles continue to follow nominal trajectories.
Looks like we did just briefly lose stage 1 telemetry. This is pretty common for this point in the flight. Stage 2 continues to accelerate towards low Earth orbit. You can see just how fast we are accelerating now. We still need to reach about 27,000 kilometers per hour in order to reach orbital velocity. As you can see, we did just
transonic.
regain signal to stage 1, and stage 1 has just passed through transonic speeds. Coming up in about 20 seconds will be the beginning of stage 1 landing burn. In preparation for touchdown on our drone ship, just read the instructions. The landing burn utilizes the single E9 Merlin 1D engine. Just starting to see that drone ship way below the rocket there.
Stage 2 has entered terminal guidance.
Stage 1 landing burn.
There's confirmation stage 1 landing burn has started in preparation for touchdown. Should be seeing those landing legs deploy soon.
Landing leg deploy. Stage 1 landing confirmed.
There we go. This Falcon 9 first stage has now successfully launched and landed for the 4th time. Coming up in just a few seconds is the end of the second engine burn.
MVAC shutdown.
We did just shut down the second engine, waiting on confirmation of good orbit.
Nominal orbit insertion.
And there it is. With that, today's landing marks our 182nd overall landing of an orbital class rocket.
Expect to loss of signal, Cape.
That includes Falcon 9 and Falcon Heavy missions. Confirmation of successful second engine cutoff and nominal orbital insertion. That will wrap up our coverage for now. Be sure to check back to our social media for confirmation of Starlink deployment.
Expected loss of signal from you.
Thank you all so much for watching, and we will catch you on the next one.